Hi, students. We're going to be looking at a couple of other identities today. These identities are a lot more like formulas instead of pieces to a puzzle for most of the uses that we have. And these are based on if you have what we think about as like the sum of two angles, and you want to know what the sine of that is. So if you had like 2 pi over 3 minus pi over 4, these would let you manipulate this in a way that we could get a value for this. Dealing with this, we often don't see things written in this fashion, but rather as a single angle that we can then rewrite as some kind of combination of angles that we know how to work with. So here are our identities. And looking at these, we pretty much are going to stay with sine and cosine. You might see a tangent one occasionally, but for the most part, these are all exactly the same type of thing. So if I had, and I think this is the example I just had, sine of 2 pi over 3 minus pi over 4. If I had that as an angle, what this is saying is that I'm going to use my sine identity. I'm subtracting, so I'm going to take the bottom stem of this. That's important because, as in cosine, we have these flipped. So if you're subtracting in cosine, we end up adding on the other side. And when I write this, so we've got alpha and beta inside here. That's going to be alpha and beta. I'm just going to plug those in here. So we get sine of 2 pi over 3, cosine of pi over 4, plus, sorry, it should be minus, like how it messed that up even after talking about that. I'm using minus, so minus for the sine one. And then we're going to have cosine of 2 pi over 3 times sine of pi over 4. These are things we know how to find the values of. We're going to use our unit circle. 2 pi over 3 for sine is going to come out to be the square root of 3 over 2. Cosine of pi over 4 is the square root of 2 over 2. Cosine of 2 pi over 3 is going to be negative 1/2. And sine of pi over 4 is going to be the square root of 2 over 2. Two negatives make a positive. And we end up getting square root of 3 times square root of 2 is square root 6 over 4 plus the square root 2 over 4. These are going to tend to look like this for the angles that we care about because these are the special right triangle angles. So why bother with this? Well, for something like sine of 15, if we want an exact value for this, we can't do that based on stuff that we know. However, I could write this as the sine of 45 degrees minus 30 degrees. That ends up being the same as 15. I'm going to use my sine formula, and again, for minus, we use the bottom one, so minus. So I could rewrite this as sine of 45 cosine of 30 minus cosine of 45 sine of 30. Getting these values, we've got root 2 over 2, root 3 over 2, minus cosine of 45 is root 2 over 2, and sine of 30 is 1/2. Again, these are just values from the unit circle, so there's no magic as far as where these are coming from. This gives us root 6, 2 times 2 is 4, and root 2 over 4. Again, I mentioned in the previous page, we're going to see a lot of things that look generally like this. That's pretty much how all of our answers are going to look. All right, so if we want to take a couple of these as examples, the tricky part is really going to be to rewrite these in terms of other values. So if I think about this, this is going to be cosine of something. I'm going to put this as over 12 over 12. I've got a negative value here, so maybe do a minus on the inside. And I want to do two things that are going to subtract to get us negative pi over 12. That might be something like 3 pi over 12 minus 4 pi over 12, which you might notice reduces into pi over 4 minus pi over 3, which are two angles that we know. Generally, with regards to these types of problems are going to be limited to things over 12 for dealing with radians, because we can write things in this way. So for cosine, I'm going to do cosine. This is a minus, which means it's going to be plus for my formula part. So we've got cosine of pi over 4, cosine of pi over 3, plus sine of pi over 4, sine of pi over 3. Doing these out, we've got root 2 over 2 times root 3 over 2 plus root 2 over 2 times root 3 over 2. And I screwed up my cosine. That should be a half. Sorry about that. That gives us root 2 over 4 plus root 6 over 4. And again, should not be shocked that we're seeing those things. Okay, I'm going to do the same thing here. Trying to rewrite this. All right, we're going to need something over 12 and something over 12. And two things that add up to 11. I also want things that'll be reducible. So like 5 and 6 add up to 11, but 5/12 doesn't reduce. So I might go with like 3/12 and 8/12. That'll give me 11, and both of these numbers will reduce for me. So we've got sine of pi over 4 plus 2 pi over 3. Sine, I've got plus. That's going to give me plus over there. So we've got sine of pi over 4, cosine of 2 pi over 3, plus cosine of pi over 4. That should not be under the cosine. Very sloppy writing. And then sine 2 pi over 3. All right, so we've got root 2 over 2. Cosine of 2 pi over 3 is going to be negative a half. And then we've got root 2 over 2, and sine is going to be root 3 over 2. That gives us negative root 2 over 4 plus root 6 over 4, and those magic numbers again. The other place that we are going to occasionally see some of these identities is with double angles. And I'm going to use one of the identities that we just talked about to show you where these come from. If I had sine of, like, I don't know, x plus x, which is the same thing as sine of 2 times that angle, we could treat this using that sine sum identity, which is going to be, we got a plus b. That gives us sine a. I'm running out of space, so I'm sorry for this terrible, terrible writing, plus cosine a sine b. If those angles happen to be the same, as in this case, we end up getting sine x cosine of x plus cosine of x sine x, which you might notice happens to be the same exact thing. So we could write this as 2 sine x cosine of x. Similarly, if we want to do the same thing for cosine, we could. That would be cosine of x plus x. And using the cosine identity, which is going to be cosine of a plus b, is equal to cosine a cosine b minus sine a sine b. Plugging those things in, we end up with cosine of x minus sine x sine x. That gives us cosine squared of x minus sine squared of x. This is useful. Actually, both of these are a lot more useful for algebraic stuff than they are for actually finding things in terms of exact values. All of the angles that we have good values for, if we were to double them, we'd end up with other nice clean values on the unit circle. So we often don't use this in terms of actually finding values for stuff. Here are our double angle identities. I'd like you to notice we've got cosine squared minus sine squared. And then that's rewritten in a couple of different ways using the Pythagorean identity to substitute either for cosine or for sine. Depending on what you're doing when solving a problem, this can be useful. We'll talk more about this when we get to solving trig equations in our next cycle of stuff. But to see where this could be done, and again, this is not something that we'd actually do, this is just to kind of see how these formulas work, I might take something like sine of 90 and rewrite this as sine of 2 times 45. So now my angle would be really 2 times theta, which is what we have here. I could rewrite this as 2 times sine 45 times cosine of 45. When we do this, we've got 2 times root 2 over 2 times root 2 over 2. We end up with 2 times root 2 over 2 times root 2 over 2. I just said the same thing twice while trying to talk about math. That worked really well. Root 2 times root 2 is 2. 2 times 2/4 is 1, which we also know is equal to the sine of 90 degrees. Again, this is not a useful computational thing, but it is really useful for algebraic stuff, which we'll see in our next cycle of stuff. For cosine, same thing. I might rewrite this as cosine of negative, let's put the 2 out front, and negative pi over 3. So I'm going to treat this, I'll just use this first one just to make our lives easier. So we're going to have cosine squared of negative pi over 3 minus sine squared of negative pi over 3. Cosine squared of negative pi over 3 is going to be 1/2 squared. And then for sine, that's going to be negative square root of 3 over 2 squared. That gives us 1/4, and then minus 3/4, which when we do that out should give us negative 1/2. And again, cosine negative 2 pi over 3, that's going to be negative 1/2. This is not a useful thing for calculation, but we're showing how we apply these things. And we're going to be using this a lot with solving equations.